Hi, my name is Thor Mejdell and I'm working at SINTEF in Trondheim. In the Align project, I've been responsible for the pilot activities at Tiller CO2 lab. At our pilot plant, we have successfully implemented and tested advanced model predictive control.
Hi, my name is Christophe Benquet. I'm Principal Technologist at Technology Center Mogstad, TCM in Norway. Our main objective is to accelerate the deployment of carbon capture. In Align CCUS project, we successfully tested the Caesar1 solvent with the real flue gas coming from a gas turbine. This solvent was found to better perform than MEA in terms of energy penalty.
My name is Georg Wiechers. I work for WP1 in the research and development, and I'm the project manager of the CO2 capture pilot plant that we operate at our power plant in Niederassuem. Here in Niederassuem we have tested 2 different solvents for 1.5 years each under the industrial conditions of a large power plant. I think it's really important to have this long-term campaign because the behavior of the solvent can change after many months of operation, and this was again confirmed here in the testing. What we found is that one of the tested solvents, the solvent called Caesar1, is much more stable than the other one, called MEA. It has also a lower energy demand for the capturing, but on the other hand, it will need more effort to avoid emissions. Yeah, and it was great how the campaigns were used from the project partners to carry out their tests with their cutting-edge measurement technologies. For example, regarding dynamic behavior of the capture plant, emissions, and countermeasures against solvent degradation. Here on site, a lot of testing has been done together with the partners, and I really enjoyed the close and the trustful work here. Yeah, and the COVID-19 pandemic, that was really an unexpected challenge. But for me it was impressive how all the partners across Europe jointly fought to achieve nevertheless the goals in Align. With our work in Align, we delivered unique results, and I'm pretty sure this will reliably help commercial applications to decide upon solvent selection, upon plant design, and also upon operating strategies. So these results can really contribute to the accelerated implementation of CCUS.
I'm Roberta from TNO, and I'm going to lead you through the main activities of Work Package 1. And for that I'll have some colleagues helping me, showing the tools that we use and the equipment that we use and what did we do. So first let's talk about controlling degradation. For that we have the DORA, the membrane that is used to take oxygen out of the solvent, and also the ChemCube, that is an in-situ tool to measure the solvent.
Hi, I'm Tarjei, and this is my setup where I test oxygen removal from my amine solvent with this DORA membrane to control degradation rates.
Hi, I'm Tanya, and along with Tarjei, I work on the DORA, and with his data I try to create models which focus on the costing and the sizing of the membrane, and we also try and figure out how well the membrane performs in removing oxygen.
Hey, we're Paul and Niels. This is our GameCube. We use it to determine the quality of amine solvents. For this we use a refractive index, speed of sound, and near infrared, for example. Why it's called a GameCube? We measure chemicals with it, so that's the first part. Formerly it was a cube, but we had to cut it because we went to RWE, and there the staircase just couldn't fit the GameCube.
On the screen you can see the amine concentration and also the CO2 concentration. Before it goes to the client, we calibrate it here and make a model for it so you can see the values.
So now that you know about our solvent management strategies, let's talk about flue gas characterization. And we do that using the FTIR and the LP.
Hi, I'm Arjen. I will present you our FTR, our flue gas analyzer. It measures permanent gases, but we can also measure things, amines like monoethanol amine, MP and piperazine, like we did at Niederassuem and at RWE in Germany. It's connected at this moment to our mini plant, and you can see it on the top of our absorber, the heated probe where the flue gas is coming from.
Hi, I'm Jasper,
This is the LP, which stands for electrical low pressure impactor. If the FPER shows, for instance, that the amine emissions in the flue gas are quite high, we can use the LP to see if these emissions are caused by aerosols in the flue gas. So with this LP, we can measure the size of these particles, and we can also measure the particle numbers. And this is also shown on this screen over here.
So this is the lab equipment that we use to make measurements on site. And with this, we can characterize the solvent and the flue gas. But we also make models out of it.
So in the line, we also do modeling. And as TNO, we are responsible for modeling a CO2 capture process on a waste-to-energy facility. And by this, we are aiming to benchmark the CSER1 solvent.
Hi, I'm Juliana, and I'm really happy with the work that we've done here at TNO within the line project. So it gives us the opportunity to look into the various aspects of CO2 capture, working with different solvents and involving the entire team from lab to modeling. But also working with a lot of different experts from the partners. It was a very fun project to work on, and I'm really sure that we have done good work and contributed to the acceleration of CO2 capture in the industry.